In this video, I'm going to do a Lagrangian problem that minimizes the cost of producing a given level of output. We have a firm that wants to minimize the cost of producing 40 units of output, given a wage of $18 and a price of capital equal to $2. Output is produced according to the production function, where K is units of capital, L units of labor, and Q is just the amount of output. First thing we're going to do is going to form the cost equation. Cost equals a wage times units of labor, where the wage is 18, plus the price of capital times units of capital, and as we mentioned here, the price of capital is $2. So we're going to minimize this cost equation subject to the constraint that we want to produce 40 units according to this production function. We'll set up the Lagrangian. So here is the cost, total cost, and this is subject to the production constraint. So it's just 40, the amount of output, minus the square root of capital times the square root of labor. We next need to take a partial derivative, first with respect to labor. So the partial derivative of 18L is just 18. We don't have to worry about the 2K, that's just 0. It's treated as a constant here. Then we have this lambda being multiplied by this minus K and L terms over here. So we're going to bring down this 0.5 in front of the lambda. And then L to the 0.5 minus 1 leaves us with L raised to the minus 0.5 power. And we set this partial derivative equal to 0. We take another partial derivative, this time partial derivative of the Lagrangian with respect to K, units of capital. So we don't have to worry about the 18L here, that's just 0, it's treated as a constant. The partial derivative of 2K is just 2, and we don't have to worry about lambda times 40, that's just a constant, so that disappears, but lambda is being multiplied by the rest of the stuff here in parentheses. So kind of as before, we're going to take this 0.5 down in front of the K. That's now going to be multiplied through by this lambda. And then K raised to the 0.5 minus 1 leaves us with this result. Once again, setting this partial derivative equal to 0. And our last partial derivative is with respect to lambda, and we just get back what's in parentheses. Our next step, we want to solve the following two equations for lambda. So our first two partial derivative results, what I like to do is simplify them down and solve them for lambda. So starting with this one right here, the partial derivative of Lagrangian with respect to units of labor, just moving the 18 over to one side gives us this result. Dividing through by 0.5, we now get 36 over here on the right-hand side. Next step, just following the rules of exponents, this L to the minus 0.5 can be moved into the denominator. And then we can multiply through by L to the 0.5 divided by K to the 0.5. Multiply both sides through by basically this reciprocal here, and you get this result. We're going to do the same thing, but now for this other partial derivative. So here, just moving the 2 over to the right-hand side, dividing through by 0.5, we now get 4 over here. Following the rules of exponents on the left-hand side of the equation, I'll move this K to the 0.5 down into this K to the minus 0.5 becomes K to the 0.5 in the denominator. And then multiplying through by the reciprocal of L to the 0.5 divided by K to the 0.5, we have another expression for lambda. So we got these two lambda equations. The next step is to set those two lambda equations equal to one another. So setting these two lambda equations equal to one another, lambda equals lambda, gives us this. Dividing through by 4, 36 divided by 4 is 9. And then I'm going to multiply through by L to the 0.5, both sides. And I'm also going to multiply both sides through by K to the 0.5. Doing that, we get K equals 9L. We're going to plug this into the production function, okay, where Q is 40. So moving that over here then. So our production function, we're trying to minimize the cost of producing 40 units. So I set Q equal to 40. And where I have a K, I'm now going to plug in 9L. So simplifying this, the square root of 9 is 3, and L to the 0.5 times L to the 0.5 is L. Dividing through by 3, L equals 13.33. I'm going to take this 13.33 here and plug it into this equation over here. So K equals 9 times L, so K equals 120. That's our cost minimizing input choice. Okay. I hope you found this video helpful.